Okay. So welcome back to the second part of the lecture. In this part we're going to do a couple things that I should have done in the previous session, previous lecture, and then we'll go show the schematic to footprint mapper, and then we'll also go into some of the homework that's coming up. So let's get going. So I can kill this off. I didn't actually show us dropping a component down that we just created, so let's do that. So I click on the little integrated circuit, and I usually do list all, and we're going to select that one, and one of them was called ELD 207. That's an opto isolator. So that's the one we just created. We can zoom in on it a little here with the mouse. So, and let's also drop another one down. And I think we called it R horiz. Oops. And there it is. By the way, I did something really awful there. I overwrote what my other R horiz symbol in there. So we may have some.
Didn't warn you?
Actually, it did, but I just kept clicking yes. So we may no. It's still using the cached value, but anyhow, I'm going to undo all these changes. So we're gonna let's get out of here. Okay, so and if you this little magnifying glass thing causes it to resize the thing to fit your screen. Okay, so the next thing you do is, after you've got your schematic all drawn up, connected and everything, is you run something called the design rule checker. I actually have to delete these things, so I'm going to hit the delete key here and here. So you see the little ladybug with the check mark on it? That is your design rule check. And you run test ERC, and because I've already made this thing pass, it passed. If we're going to close it, and we're going to do an undo to bring back both those components. And now we're going to run the design rule checker, and we're going to fail dismally. Okay, you're going to say, huh? There's an item not labeled called R. So let's take a look. And sure enough, we didn't label two components. So how do you label components? Well, you can do it by hand. You can edit those. We can drop in on one of these symbols. Let's drop it on the resistor. And we can edit the reference. Change the question mark to a value. That's the hard way, guys. Let's not do that. So the easy way to do it is to use the automatic annotation system right next to the design rule checker. And it gives you a whole bunch of options. For me, I just hit annotation and click OK, close it, and now it has, for each reference letter chain, it picks the next one in the line. So we had 4 resistors previously, now we have a 5th one. U4, we were up to U3. So that's how you force the annotations. So it's the, I don't know, how do you describe that thing? It's a little inverter with a, I don't know, a wand, a little star, I don't know. Sometimes these icons, I don't know. So anyhow, that's what we're going to do. So I want to delete these because we want to go on to the next step, which is netlist generation. So I'm going to run the design rule checker one more time, verify that we're okay, we are. And now we go to the net. Now right after the ladybug with the red, with the check mark, is the wrench with the .net. And this creates something called the netlist. The netlist is sort of the file that is used to communicate from the schematic to the printed circuit board. And really, you just click netlist, and say save, and it is done. Okay? And you'll see a file in that directory called .net. And actually, I should just bring it up just so you can see it. Oops. And this is the format of it. It basically, sorry. It's just a list of components connected to other components, and it tells you where everything goes. Okay, so you don't really need to look at that or edit it or anything. It is a generated file. So now that we've done that, we go back to the main launcher thing, and you see this thing that has the little schematic FET on it going to an IC. This is the converter, the mapper. And I have a bug. I don't know where it says it's asking for this SMD DIL. I just click OK. I don't really need it. Okay. Now I have already mapped this device. Okay. Now what I want to, can I zoom in on this, or is this one of these you can't zoom it? No, it's not zoomable. So this column here is the various components by their reference letter. So we have 9 capacitors labeled C1 through C9. We have the 4 mounting holes. We have a jumper. We have 2 connectors, 4 resistors, 3 integrated circuits, and 1 crystal. Okay. And then these are the the various values we gave to them. So like we have a 0.33 capacitor, 0.1, 18 puff, 0.1, etc. The resistors 10K, 10K, 24K, 124 ohm, 1% resistor. And then the ICs, we have like the Max 3051, we have a voltage regulator, we have the microcontroller chip, LPC 1754, and we have the crystal, 20 megahertz. Okay, this column is the footprint names. Now, next lecture I'm going to go into something called IPC 7351, which is the Integrated Circuit Industries standard labeling for footprints. I think it's a very credible, usable naming system, so I use it. Okay, I'm not going to go into too great a detail here, but you'll see this thing that says Cap C 1608. Okay, the 1608 is the metric size of the 0603 capacitor. Okay, and it's up to discussion whether or not it's hundredths or tenths of a millimeter, right? I think it's hundredths. I could be wrong. I was wrong last time, so I'm willing to admit when I'm wrong. Okay. The other thing is you'll see an X followed by a 90. The 90 is how high the component is. Okay. You say, footprints, who cares about height? You, as a PC board designer, you could care less about height. If you're going to manufacture this thing, you need to know how high the part is so that the pick and place machine doesn't try and shove the part through the board. So it has to know the height. So that's why the footprints have a height in them. Okay. Go down here to resistor. Resistor is 1608 x 50. So resistors are a little flatter. The last letter is N, and it stands for nominal footprint. I'll explain that all next time. So what we're going to do is we're going to scroll through here, and I don't know. We're just going to pick one of these at random. and I double clicked on it, and I just turned the capacitor from a this footprint to an LED 5mm footprint. We can do all sorts of crazy things here. Okay, this one would actually work. That's an LED 0603. There will be checking that goes on later, but for now you can do any assignments that you want. So I'd like to fix this up, and let's go to the cap. And no, there are ways of getting around having to scroll through this entire list every time. Where's cap? I don't see. There's something wrong. My capacitor isn't showing up. Anyhow, I'm not going to be able to fix it up. So when you're done, you basically use this to write the thing out. And now the printed circuit board editor has a netlist and a list of footprints to work with. And so at the next class, we're going to go deal with starting to lay out the board. But it's key to understand that in KiCad, footprints aren't bound to components until this step. Other editors, other tools, bind the footprint in the schematic editor, okay, but not KiCad. And some people really like it that way, and some people say, well, that's not really the right thing to do. There's discussion. So now I'm going to change gears, and we're going to talk about homework. Okay, let's see if I can type clear here. Okay, now for how many of you have heard the term pedagogical? Pretty much all of you.
I don't know what it means.
Okay, it basically means we're going to be doing something that makes sense from an instructional point of view, but you may not be all that interested in the result. So this last time I asked most of you to try and take a pin from the microcontroller and run an LED into a resistor to ground. How many people were able to do that? I know one of you couldn't even get the KiCad up. So you got it. Uh-oh, we're falling behind. We're going to have to...
Right after the class, I'll do it.
What? We're going to have people stay in after class. Okay. And here's the erase. So, what we want to do is build a board that has a fair number of surface mount parts that we can assemble on it. Okay. So what I've decided to do is, just because it's fun, is we're going to do an 8x8 LED array. So what we're going to do is we're going to have and the 8x8 isn't the magic number. It's just we want rid of these things. Okay, so if you're having troubles fitting it onto the schematic, drop off the ones you don't need. Okay. Now, most of you have seen those scrolling LED panels. I actually think there's some of them around. I think there's one out on the other side. Well, the way those work is they actually light one column at a time, and they flash it. And because the persistence of vision of your eye, you don't see the flashing. It's the way televisions and movies work as well. So what we want to do is we want to design a system that can do that. Now, the way you do that is you take 8 pins across the top, and you run those to your microcontroller. Okay. And then you take the other ones and you hook them in a column like this. So, but you always wondered how that worked. Now, because we only turn on one column at a time, all these things don't turn on. And then we enable the individual LEDs to get them to go. Okay, and then we need to have some sort of current limit resistor to ground. Okay. So what I'd like you to do is, for the next class, see if you can draw out some sort of LED grid. Okay. And I have some, well, we're shooting for 8 by 8, but you may have some problems with this, fitting it all in the schematic. If you need a little space in the schematic, feel free to move the microcontroller over a little, make a little bit of space. You know, you own the schematic. You can do whatever you want. Okay, oh, sorry, this doesn't go to ground. My apologies. This goes to another 8 pins on the microcontroller. And we'll talk about why this won't actually work for real. It has to do with the fact that the microcontroller can only source a certain amount of current. So we're actually going to have to put some drivers in the next iteration. But if we can, this will give you people a chance to start working on this stuff. What I'd like you to do is, if you experiment with the library editor, why don't you create a vertical one-hump resistor and use that. Okay, that'll make Luke happy when he sees the schematic. Okay, and that's just to get it to try it out. Okay, so that's homework. I've typed a whole bunch of stuff up in the home page for the class, suggesting what we want to do. The other thing we want to do is, I'm a big believer in storing our projects in GitHub, so I'm recommending people use GitHub and create a GitHub repository, put their project in there, and that way we can, when you sit there and say, hey, I'm having problems, you just send me a pointer to your GitHub, I yank it down and I can look at it and we're ready to go. Rather than you trying to say, well, here, I'll try and put this stuff up into a zip file, oops, I missed that file. You get the idea, so that's the thought. So I'm going to hit the red button, sayonara for the lecture, and then we'll do question and answer.